Welcome everyone in our this topic, which is a combination of a capacitor in series and parallel combination. So in the last video we saw few things about the parallel combination. We will continue in the session also. So parallel plate capacitor. It consists two plates, parallel conducting plates, separated by a certain distance. So if I'm supposing this will be a plate, both are parallel. What is the mean of a parallel? The distance between these two plates are constant. If the D will be constant, then we are saying that plate will be parallel plate. Hope I'm clear. Next we have the distance between the plates is kept small. So what actually we are taking the value of a D, D becomes the very small value. Now this is a parallel plate capacitor. As you can see, the length of the particular capacitor or plate and the another length of the plate. According to the length, the separation is a very less in amount. And we know the field lines of electric field lines, it will be start from the positive and end up of the negative. Clear? Principle of a parallel plate capacitor. To increase the capacity of a one conducting plate A by bringing another conducting plate B close to it to decrease the potential at the small or same changes or same charges. To increase the capacity. What is the mean of that? So parallel plate capacitor is basically a capacitor by which we can use the capacity increasing data. One conducting plate A and another B. So let's say if I'm supposing this will be A and this will be B. So again the distance of a D is very small. Clear? For more elaboration, let's see here. Explanation. It follows three cases. First step, these are the parallel plate capacitor. If I'm just taking the plate A and B. So initially, by the help of a potential, the charges are accumulate over there. But because of induction, the charges are, if this will be a positive in nature, so similarly the opposite type of a nature of a charge will be stored there. Clear? So let A and B be with the two conducting plates. A as a positive charge and B have a no charge initially. Now we bring the plate B near the plate A without any contact with each other. Step 2. When the uncharged plate B taken is closer to plate A, due to the induction, negative charges is induced, as I told you, on the one face of the plate B, the left. An equally positive charge created on the another face of the B, like this. Now, the induced negative charge on the plate B tends to decrease the potential at particular point A, whereas induced potential or induced positive charges on the B tends to increase the potential of a plate A. The main term is over there is induced negative charge of a plate B tends to decrease the potential A, and induced positive charge of plate B tends to increase the potential of plate A. Next, therefore the net potential of the plate A is decreases. Step 3. Now we connect the plate B to the earth. There is a flow of negative charges from the earth to the plate B and positive charges of the plate B. Both charges will be neutralized so that potential of a plate is further decreased and capacitance will be increased. Now only induced negative charges exist on the plate B. For more elaboration, let's see some questions are there. Dimensional formula of a capacitance is. We have an options are these. So The correct answer for this question is option B. Next we have a symbol of a variable capacitors. As you can see clearly, which is a variable. Only the option D. Capacitance of a parallel plate capacitor. So capacitance for a parallel plate capacitor is, if we just take in a parallel plate capacitor whose one surface charge density is plus sigma and another charge density is a minus sigma, then, and the separation which we assume that is a D of two plates of a capacitor. Let plate A has a positive and plate B has a negative charge. Sigma with the surface charge density of the plate A minus sigma is the surface charge density of the plate B. E be the electric field between those plates. We know that E is equals to sigma by epsilon naught, which I am assuming as a equation number 1. But E is equals to V by D. Here I just want to elaborate few things more. If I just take in two plates, and the first plate, as you can see over there, this will be positive, and after doing the earth, the another plate will be negative. The first surface charge density is sigma plus and the other negative sigma. We know that because of this positive charge, they have some electric field lines. So for this positive charge, the electric field lines will be radially outward. And for this negative, electric field lines will be radially inward. So as you can see over there, if I'm just taking for a negative charges, for negative and for positive field lines. So here, this is the situation. This is the for E plus and this is the for E minus. They are opposite in the nature. If they have the same accumulation of a charges, so the net electrostatic field over there will be 0. In the mid, they have the same direction. That means for a single plate, we know the electric field intensity for a single plate capacitor, that is sigma by 2 epsilon naught. So we have a 2. So plus sigma again by 2 epsilon naught. And this will become sigma by epsilon naught only. Next we have again the different directions. So E plus, E minus, this will be gives, E net will be 0. For that scenario, we can say inside the capacitor electric field is sigma by epsilon naught, which I just make over there. E is equals to V by D. This value comes from the negative gradient of a potential energy, or simply we can say it is a relation between electric field and potential. If you calculate the value of a V from here, so substituting the value of equation 1 into, we get the value of a V is sigma by epsilon naught into D, and the sigma is a Q by A. What is sigma over there? Surface charge density. It is the surface charge density. Now substituting the value of a 3 into, we get V is equals to Q by epsilon naught A into D, or we know C is equals to Q by V. We just put the value of equation number 4 in 5. And we get the value of a capacitance, which is epsilon naught A by D. As you can see over there, the C is, it depends the permittivity and the A, that means what is the area of that, and distance between them. If we decrease the value of a distance, capacitance will be increased. Note, C is directly proportional to A and C is inversely proportional to D. Effect on dielectric on capacitor. So, capacitance of a parallel plate capacitor with a dielectric slab. If we have a capacitors, as you can see, we have a two capacitor. One have a positively charged in the nature, another have a negative charges. Because of induction, if we just put a dielectric over there, because of induction, a negative charge, series of negative charges created over there, and series of positive charges created over there. Because of that, a self-induced electric field created, and the direction of induced electric field is a negative, or we can say opposite in the direction of actual electric field. If the thickness of this dielectric slab is a t, and the complete distance which we are always taking as a small d over there. So, A and B are two parallel plate capacitors. There are in vacuum or air filled between these two plates. We know C is equals to epsilon naught A by D. Here C naught be the capacitance of a parallel plate capacitor in vacuum or air. If we generate a medium, the value becomes changed in this form. Epsilon naught K will be arises over there. And K is that medium constant. Now, epsilon naught be the absolute permittivity of a free space. A be the area and D be the distance of a separation between the plates. Now let us introduce a dielectric slab between the plates. So let T be the thickness of a dielectric slab as a supply the electric field vector E to the dielectric slab between the plates due to the polarization by applied electric field E naught, equal and opposite charges appear on the two faces of a dielectric slab. These induced charges are able to raise induced electric field, which is EP, which is equal and opposite to the applied electric field E naught. Then resultant field or reduced value of electric field is E is equals to E naught minus EP. Here E is equals to E naught minus EP exists in the region of a thickness. Now potential difference between these two plates are this. V is equals to E naught D minus T plus ET. K is equals to epsilon naught divided by epsilon, or here the value of K, which is a medium constant, we can write over there E naught, which is the value of initial velocity, initial electric field, and after field changement, that means after inserting the dielectric, this will be E naught by E. So we can calculate the value of E. This will be E naught divided by K. Substituting the value of 3 in equation 2, we get V is equals to E naught D minus T plus E naught by K into T. V is equals to E naught, if I am just common, 2 common, so D minus T plus T by K. This comes into the nature, which I am assuming as an equation number 4. We know that E naught is equals to sigma by epsilon naught. I am just putting all these values. So we get the value of the E naught, which is a Q by epsilon naught A. And the final result which we receive, that is a V is equals to Q by epsilon naught A. D minus T plus T by K, which is equation number 6. Now we need to find the value of the capacitance. So we know C is equals to Q by V. What we can do? We just put the value of equation number 6 in this equation and get the value of a capacitance. Means we have to substitute the value of 6 or equation 6 in the 7. We get the value of a capacitance epsilon naught A D minus T plus T by K. If I do common the value of a D, so epsilon naught A divided by D, 1 minus T by D plus 1 or T divided by dk. Substituting the value of 1 in the 9, we get C is equals to C naught 1 minus T by D plus T divided by dk. C by C naught comes 1 divided by 1 minus T by D, 1 minus 1 by K. This is equation number 10. It is clear that C is greater than C naught. And capacitance of a parallel plate capacitor increase on introduction of a dielectric slab between the plates of a capacitors. Note, If T is equals to D, then C is equals to C naught 1 by K. That means K C naught. K is equals to C by C naught, which is called as a dielectric constant. Move ahead with some questions so that we can understand which topics we cleared, have we understood or not. Formula for capacitance of a parallel plate capacitor with dielectric slab is. The correct answer for this question is option A. Hope you understand. Moving ahead with the next question. Capacitance of a parallel plate capacitor is C is equals to D by epsilon naught A. C is equals to epsilon naught A divided by D. C is equals to epsilon naught A D minus T plus T by K, or C is equals to epsilon naught A divided by D. So among all these options, which option is the correct? Yes, the correct option is C. Combination of capacitors. Combinations of a capacitor. The first we will see the capacitors in series. As you can see that we have 3 capacitors which is connected in the series. Initially the plates of the charged capacitor is uncharged. Let plus Q be the charge to the left plate of the capacitor C1. Due to electric field, this positive charge plus Q pulls the negative charge minus Q up to the right plate C1. Till the electric field lines begins from the left plate and end from the right plate. Therefore, the right plate of C1 acquires negative charge. This negative charge comes from the left plate of C2. Through the wire connected to them. Therefore, the left plate of a C2 becomes positively charged with plus Q charge. The right plate of a C2 acquires negative charge as explained for a capacitor C1. Similarly, capacitor C3 charged with the Q charge on the left plate and negative on the right plate. Thus, each capacitor have the same charge when they are connected in series. Let V be the potential difference across the arrangement, and we will divide as a V1 plus V2 plus V3 or V1, V2, V3 form. Let the capacitance of the capacitor will be C1, C2 and C3. So net potential will be V1 plus V2 plus V3. But we know V is equals to Q by C. So V1 is equals to Q1 by C1. V2 is equals to Q2 by C2 and V3 is equals to Q3 by C3. This I am assuming as a next equation. Substituting the value of 2 in equation number 1, we get Q by C is equals to Q by C1 plus Q by C2 plus Q by C3. Hence, if we do common the value of a Q, we cut it the value easily and get the result 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C3. If n capacitors are connected in series, so we have a formula 1 by C is equals to sigma. Again, this sigma introduced for the discrete summation. Not continuous. Note B which we have to do. If 2 capacitors are in series, the formula will be 1 by C is equals to 1 by C1 plus 1 by C2. The next thing, C is equals to C1 C2 divided by C1 plus C2. Next, which we have a capacitors in parallel. So these are the capacitors which, as you can see, connected in the parallel combination. From the diagram, these are the 3 capacitors C1, C2 and C3. When a potential difference V is applied across the A and B, all the capacitors have equal potential across B. Since each capacitor have the same potential difference across E, that means it is the position where store the charges according to the capacity. Hence, capacitor have a different amount of charges. If the charges have a different amount, so we can accumulate the charges like in the form of a Q is equals to Q1 plus Q2 plus Q3. This is the equation number 1. We know that Q is equals to Cv. We just put these values like Q1 is equals to C1V, Q2 is equals to C2V, Q3 is equals to C3V. I'm assuming this is the equation number 2. Substitute the equation number 2 in 1. We get Cv is equals to C1 plus C2 plus C3 into V, or C is equals to C1 plus C2 plus C3. If n capacitors are connected in the parallel, so we have again discrete summation C is equals to sigma I is equals to 1 to n Ci. Let us move some questions. Formula for effective capacitance in different capacitors when they are connected in parallel. I hope you did. The correct answer for this question is option A. Second, formula for effective capacitance of a different capacitor when they are connected in the series combination. So we have this questions. We know that if they are connected in a different capacitor but in the series combination, so the formula will be 1 by C is equals to 1 by C1 plus 1 by C2 plus 1 by C3. Hope you understand this topic. Wait for the next topic. Till that, take care everyone.